Welcome to Brain Vision.
Hello everyone, this is a solution to problem 30 of chapter 24 of college physics. We're given some basic information about the power radiated by the sun, and we're asked to find what the intensity of that power incident on the surface of the sun and at a distance away from the sun that is equal to the Earth-Sun distance. So to answer the first part of the question, we are told what the radius or the diameter of the sun is. So assuming that the sun is a spherical surface, then the intensity is going to be equal to the power radiated by the object over the surface or over the area over which it radiates. And again, so assuming that it has a spherical surface, we have that this is going to be 4 pi times r squared, but r is a half of the s, so this is going to be 1 over 2 times d s squared. And so putting in the values for ds and the power, you find that this is equivalent to 6.34 times 10 to the 7 watts per meter squared. So this is the intensity of the sun on the sun's surface. Now in question B, we're asked to find essentially what is the incident power on the on 1 square meter of Earth, but that is basically equivalent to asking what is the intensity at a distance of RES, so 1.5 times 10 to the 11 meters away from the sun. And so to calculate the intensity there, we just have to divide by this larger area over which the same power is radiated. So this will be P over 4 pi, and this time it's going to be RES squared. And so again, putting in the values here, you find that this is 1.37 times 10 to the power of 3 to the power of 3 watts per meters squared. And so the power incident on 1 square meter of Earth is just 1 square meter times this quantity. So power on Earth for 1 square meter, so 1 meter squared, is equal to just 1.37 times 10 to the 7, 10 to the 3 watts. So that's the answer to part A and B. And so the assumptions that we made in part B was that the sun was uniformly radiating in all directions away from it. So it's uniformly radiating in this direction, and this direction, and this direction. And so there's no change in the intensity as you go around the sphere around the sun. So this is our answer.